Now here we are with video 2, or part 2 of section 2.3, and we left off where if we were given the diagram, it wasn't too difficult to find delta. All we had to do was a little bit of a subtraction and take the absolute value and then pick the biggest one. Now the question becomes, how can we get those additional x values? And that's what the next group of problems deal with. So let's begin with example number 3. Example number 3, we have f of x equals negative 9x plus 8. We have L is equal to negative 10, so we know our limit is negative 10. X sub 0 is equal to 2, so in other words, the limit as x approaches 2 of this better be negative 10. Quick check. Negative 9 times 2 is negative 18. Negative 18 plus 8 is negative 10. So that's really no big surprise. And then we get our epsilon is 0.01. Now, like I said, a lot of times graphs just aren't that great, but let's deal with it. Okay, the y value. We know that the limit is negative 10, so we're going to put negative 10 here. And then epsilon tells us how much is it going to change from one to the other. And so if we go up 0.01, then that's going to be negative 9.99. And if we go down 0.01, that's negative 10.01. And we're going to have to find the equivalent x values. Now x value here should be pretty simple. That's 2. But now we have to find this one and this one. But realize any place where we have negative 9.99, that's just what this value is right here. So all we have to do is say, okay, I'm going to take negative 9.99 and set it equal to negative 9x plus 8 and figure out what x is. So I'm going to subtract 8, negative 17.99 equals negative 9x, and then divide both sides by negative 9, so that x would equal, after some rounding, 1.99. So we've just worked in reverse to get the x value. This is inverse functions, basically. Indirectly. But anyway, you see where I'm going with it. Then, if the y value is negative 10.01, once again, all we have to do is set it equal to the function, subtract 8, and divide by negative 9, so that x equals about 2.001 after doing some rounding. Now you have to have just a common sense rounding here, because you don't want to carry out the whole mess that's here. Okay, and so this would be 2.001. Now we could spend a lot of time, but basically the question now becomes, what would delta 1 become? In other words, what's the difference between here and here? Well, hopefully that's pretty obvious. That's just 0.01. Okay, and what's the distance from here to here, which I'm calling delta sub 2? Well, that would be 0.001. And just like last time, we have to pick the biggest delta so that it's all covered. So we can either pick 0.01 or 0.001 for our delta. And the biggest one here is 0.01. And so our final answer would be delta is 0.01. Example number 4. Same thing. I'm going to write the information, and then we'll go with the graph, or the very rough graph. F of x equals 5x squared. The limit is 245. X sub 0 equals 7, and epsilon is equal to 0.3. Is equal to 0.3. And so, very quickly, we know our limit is 245. So I'm going to put my 245 right here. My epsilons are 0.3, so I can have one here and one here. If I go up 0.3, that'll be 245.3, and if I go down 0.3, that is 244.7. Now we need to see where do they show up on the x values. Hopefully it's rather obvious what goes right here. Hopefully you see that is 7. And of course it wouldn't take too much to realize 7 squared is 49. 5 times 49 is 245. So that's where we want it to be. But now we need to figure this value here and this one here. And remember, we have to find the actual x value given the appropriate y. So I'm going to first off try to find this one here. So it's going to be 244.7 is equal to 5x squared. Divide both sides by 5 and x squared equals 48.94. Take the square root of both sides, and we only have to worry about the positive because we're dealing close to 7, so we know it's the positive, and that is 6.996. So that's what goes here, 6.996. Now we want to get this value over here. Well, once again, 245.3 equals 5x squared. Divide both sides by 5, so that x squared equals 49.06, and then take the square root of both sides, so that x would equal 7.004. Now once we get these points and everything lined up, it's just very simple from then on. We need to find the distance. What's the distance between 6.996 and 7? In other words, delta sub 1 would be 0.004. What's the distance between 7 and 7.004, or delta sub 2? It's 0.004 also. Which of these two is bigger? Well, in the overall scheme of things, one of these I'm sure would round out further and be a whole lot bigger, or not a whole lot bigger, but a little bit bigger than each other. But these certainly are close enough to say that delta would be 0.004. Okay. Example number 5. Let's see what sort of fun we can have here. Example number 5, we're supposed to find the limit given all the information, then find the number delta such that the definition applies. Basically, the definition applies is a way to say that whole mess that I gave you at the beginning of the first video. Number 5, we're told f of x is equal to the square root of 115 minus 5x. X sub 0 is equal to 3, and epsilon is 0.5. First thing we need to do is we need to find limit. Well, the limit shouldn't be too hard. In other words, we're trying to find the limit as x approaches 3 of the square root of 115 minus 5x, which simple substitution will work here. Square root of 115 minus 5 times 3, which equals the square root of 100, which equals 10. So we have L is 10. So now we can put in our 10 there. We know we're going to have one above and one below, and in particular we're going to go 0.5 in both directions. So this will be 10.5, this will be 9.5. And then we want to have the corresponding x values. Now, just like all previous problems, this x value right here should not be difficult. This is 3. How are we going to find these? We need to plug these in and then do some calculation. So we will get 9.5 equals the square root of 115 minus 5x. Square both sides, and we get 115 minus 5x equals 90.25. Subtract 115. Negative 5x equals negative 24.75. Divide both sides by negative 5, and x equals 4.95. Okay, now this is quite a change. We've got quite a wide variety right there. In fact, delta sub 1 will equal 1.95. It's pretty big, but we can still determine it. And I guess in the overall scheme of things, of all numbers known to man, 1.95 is relatively small. Now let's do the same thing for calculating for 10.5. So I've got 10.5 equals the square root of 115 minus 5x. Square both sides. 115 minus 5x equals 110.25. Subtract 115 from both sides. Negative 5x equals negative 4.75. And divide both sides by negative 5 so that x equals 2.05. Once again, quite a healthy spread, but you know what? We can calculate what the actual distance is there. So now we're ready to look at this and say, okay, what is delta sub 2? Well, with a slight fairly simple calculation, 3 minus 2.05, take the absolute value, it's 0.95. Now this rule has not changed since example number 1. Which of these deltas will actually represent the delta we want? Well, we picked the biggest one. 1.95 versus 0.95. I think it's rather obvious. 1.95 wins. And so the delta that we are asked to find is the biggest one, or in this case, 1.95.